All right, now that we have done basic transformations on sine and cosine, we're going to look to see how to do transformations on the reciprocal and ratio functions, your secant, your cosecant, tangent, and cotangent. All right, so we're going to start with cosecant. So cosecant is closely related to sine because it is just simply the reciprocal of sine. So let's look at some key features of cosecant. First and foremost, let's talk about the domain of cosecant. Well, cosecant is going to have some asymptotes in there. And the reason why is because everywhere sine is 0, we're going to have 1 over 0. And whenever we have 1 over 0 when we're graphing, that's a vertical asymptote. So my domain is going to be the set of all x's such that x is an element of the real numbers. And let's think where sine is 0. Well, sine is 0 everywhere it crosses the x-axis. Well, it starts at 0. So, and then it repeats every pi. So I have to say x does not equal pi k when k is an element of your integers. All right, now I know this looks confusing. It really isn't when you think about it. The sine wave is going to be 0 on every increment of pi. At 0, at pi, at 2 pi, at 3 pi, at 4 pi, at 5 pi. If you notice, I'm counting up by ones. 1, 2, 3, 4. That's what this k is because that's an integer. It's also 0 at negative pi, negative 2 pi, negative 3 pi. That's where we have integers. And if I put 0 in there, 0 times pi is 0. That takes care of our 0 degrees, sine of 0, which is 0. All right, so there is our domain. My range is going to be, we're going to go from negative infinity up to negative 1. We're going to skip over to 1, and we're going to go to infinity. What's really interesting about this is in this gap right here between negative 1 and 1, that's where sine's at. Sine is between negative 1 and 1. Cosecant is everywhere else sine isn't, but they do share negative 1 and 1. All right, what about amplitude? Does cosecant have an amplitude? Because sine has an amplitude. Does cosecant? Well, the answer is no, because to have an amplitude, you have to have a maximum and minimum. There is no minimum because we're going to negative infinity, and there is no maximum because we're going to infinity. So this does not exist. And what about the period? Or how long does it take to repeat? Well, sine takes exactly 2 pi, or 1 full rotation of a circle to repeat. Cosecant is going to be the same as 2 pi. So let's take a look at the graph of what it actually looks like. What I'm going to start with is I'm going to graph a sine wave. So this is kind of what sine looks like over 2 periods, one in the positive direction, one in the negative direction. This is going to be pi, this is 2 pi, this is 0, this is negative pi, and negative 2 pi. Okay. Now, we're graphing cosecant, not sine, but I drew sine in. Well, the reason why I did that is I'm going to use this to help me graph cosecant. Because everywhere this graph of sine touches the x-axis, is where it's 0, is going to be a vertical asymptote. Because that's going to make this value right here 0. We cannot have 0 in the denominator of a fraction. I'm going to draw in my vertical asymptotes. So right here at negative 2 pi, right here at pi, and that once again fits in here because if I pick negative 2 as an integer, I'd have negative 2 pi. 0 is also an asymptote. You notice how I'm using a dashed line. Asymptotes, when you graph them, are denoted by a dashed line. And then we have one at 2 pi. Okay, so I now have my asymptotes drawn in. So now I'm ready to actually graph cosecant. So when I look at this, I've got a maximum here, and I have a minimum here. And here I said my sine is sandwiched between them. So everywhere that there's a maximum, or the 1, I'm going to have it approaching infinity. So 1, I'm going to go up to infinity. It's going to look kind of like a parabola, but it's going to be sandwiched between these asymptotes. At a minimum, I'm going to go to negative infinity. So it's going down. And then we just keep doing this over and over and over again on the sine wave. And we can leave the sine wave in there, or we can erase it to see what the actual graph looks like. So if I erase just the sine wave. You'll be able to see just the graph of cosecant. Now I can't erase it perfect, but I can get pretty decent to it. So as I erase it off, there, ladies and gentlemen, is the graph of cosecant. So it looks different than what you're used to seeing, but everything matches up with the domain, the range. There is not going to be an amplitude, but the period does repeat every 2 pi. Because if you look here, it's on top, on bottom, the next one's going to be on top, then bottom, on top, and then bottom. It just repeats itself every 2 pi. All right, let's look to see how to do transformations on cosecant. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.